let's do some guided practice. I know we're not technically starting in the guided practice section, but Lecture 18 derivative review doesn't involve learning anything new. We're just doing a bunch of practice problems. So let's do all the following practice problems together. Note that you are responsible for the derivation of these formulas and that I did only one of them, right? So see if you can do the other two for arc cosine and arc tangent, right? See if you can show that their derivatives are negative 1 over the square root of 1 minus x squared and 1 over 1 plus x squared. They're analogous to the arc sine derivation. But if not, then ask me tomorrow. Anyway, let's do the following practice problems together. Now note that this is chain rule galore here, right? The outer function is x squared, so the derivative is 2 arc sine of x. Then we have to multiply by the derivative of arc sine, which is 1 over 1 minus x square root of 1 minus x squared. You can leave it like that. You can also write it as 2 arc sine over 1 minus the square root of x squared. Here, we've got the dy over dx is going to equal, and this is a product rule, right? So we have 1 over square root of 1 minus x squared times arc cosine of x. And then this is going to be plus arc sine of x times negative 1 over the square root of 1 minus x squared. Okay? So if you wanted to simplify this, you could write this as arc cosine of x minus arc sine of x all over square root of 1 minus x squared. Now g of t, right? G prime of t. What have we got here? Well, another chain rule problem, right? So we have 7 times all this stuff in parentheses to the 6th times the derivative of the inside. Well, that's going to be e to the arc sine of t times the derivative of arc sine of t, right? Which is 1 over square root of 1 minus t squared. Just put it down there. Plus, and now it's going to be 5. Now remember the derivative of arc cosine is 1 over 1 minus, now it's got to be the inside squared, right? Or actually, it's negative, right? It's negative that, right? 6t quantity squared. And then we have to multiply it by 6. Trying to make that a nice parenthesis. Whoop. Man, can't really make that a nice parenthesis. There we go. So that's right. So you can clean that up a little bit if you want, but that's your answer. All right, and I say to try these in groups of 3 or 4, but let's see if we can just knock some stuff out now, right? See if we can find the derivative. Right now we're combining implicit differentiation with inverse trig functions. So we're going to get 1 over the square root of 1 minus x squared y quantity squared, right, that whole thing squared, times, so maybe I'll just put it in the numerator here, the derivative of x squared y. That's going to be 2xy plus x squared dy over dx. And then plus 2. And then 2y dy over dx, remember chain rule. Plus 8 arctan of 6y, so that's going to be 8 over 1 plus the quantity 6y squared. But then it's going to be times 6 dy over dx, because that's the derivative of 6y. All right, now, a little messy here, right? We've got to get the dy over dx terms on the left side and the non-dy over dx terms on the right side. Whew, let's get to work. This is not going to be quite as bad as it looks, right? We're just going to split this fraction, right? Split it. And then we're just going to subtract all the other things over, right? So we're going to be left with the x squared over 1, square root of 1 minus x squared y quantity squared dy over dx. And then just to show you what happens to this part right here, we're going to subtract it over, right? We've got negative 2xy over the square root of 1 minus square root of 1x squared, right? We just subtracted that part over. Okay? We're also subtracting over the 2. But then we're going to subtract over on this side the 2y dy over dx. And I guess I have to move this a little bit, I suppose. It's going to be minus, I guess it's 48 if we combine the 8 times 6 over 1 plus the quantity 6y squared dy over dx. Right? So you see we've got all of that, right? And then at this point, let's just kind of factor out the dy over dx and divide, right? So we're going to get this lovely, lovely answer. Needless to say, I would not expect you to simplify in this situation. Right. So that's how you do that problem. Find the equation of the tangent line to this. Now this is just kind of review. Right? This is just sort of review. And it's worth noting that y equals this, but it really equals 1 over x squared plus 1 over x plus 1, right? And we're allowed to do that, right? We're not dividing by 0. Like, we're not really changing any answers, right? We're at the 0.2, right? So anyway, we've got this. Now we take its derivative. It's going to equal negative 2 over x cubed minus 1 over x squared, and then that goes to 0. And we want to evaluate this at the point x equals 2, right, at the value x equals 2. So that gives us negative 2 over 2 cubed minus 1 over 2 squared. And that's going to give us negative 1/4 minus 1/4, which equals negative 1/2. Right? Now, they're asking for the equation for it, so the line has equation y minus 7/4, it's a 7, y minus 7/4 equals negative 1/2 times x minus 2. And if you want, you can solve that for y, but that's what it is. I think it's y equals negative 1/2 x plus 11/4, I think, if I did that right in my head. Right, now, just to be clear, this looks very complicated, a whole bunch of chain rules, but it's really not. Remember, sine of arcsine cancels out, right? So we have that the derivative with respect to x of sine of arcsine, this isn't even a derivative thing, this is just a definition of arcsine thing. Is going to give us, right, this is the same thing as the derivative with respect to x of, right, these guys cancel, right? It's like, again, it's like the square root of x squared. So we're just left with 8x to the 5th plus cosine of x, and that, of course, is just 40x to the 4th minus sine of x. That's it. Right, now we come to guided practice, and I think it's just these 3 problems, yeah, right? So, find the derivative of the implicit function, right? That means find dy over dx, and you're going to have to implicitly differentiate, right? So remember, be a little careful here, we've got a product rule for that first term. We're going to get 3y squared dy over dx, x squared plus y cubed times 2x, right? Does everyone see that this right here is the derivative of this? Plus 1 times y, maybe I'll just write that out more explicitly, 1 times y plus x times dy over dx. And does everyone see, I hope, that this is the derivative of this? Okay? And all that's going to equal 5x to the 4th. And then we just solve for dy over dx, right? So we're going to get 3. Convention, you put the x's before the y's. Right, and then let's just factor out the dy over dx equals 5x to the 4th minus 2xy cubed. So let me just divide. Let me get that. That's our answer. Right, if they give us a point, we'd plug them in for x and y, right? But they didn't, so we won't. Let's see what's going on here, right? We get 3x squared plus y squared, right? Because the outer function is x cubed, times the derivative of the inside. Plus, oh, lovely, a quotient rule, right? Not the worst thing in the world, right? Low d high minus high d low all over low squared. It's going to equal 0, right? Oh, I think I forgot that thing right there. Okay. Let's see what else we've got. All right, so when we do this out, right, we're just going to distribute this and this. Right, we're going to wind up getting 6x times x squared plus y quantity squared plus 3x squared plus y quantity squared dy over dx. Whoops. Oh, and then this is going to be plus, and I guess this will be 1 over y, right? I'm going to separate these, minus x over y squared dy over dx, and that's going to equal 0. And so putting the dy over dx terms on the left, putting the other terms on the right, factoring out, blah, blah, blah. See if you can follow me on this one. I'm just going to state the answer at this point. It's dy over dx equals, well, what is it? We're going to be dividing by 3x squared plus y quantity squared. It's minus x over y squared. And on the top, it's going to be negative 6x times this lovely thing, minus 1 over y. Right? So that should be our answer. If you don't believe me, then do a couple steps of arithmetic. Make sure I got the right answer. Whoop. And now number 3, right? Arctan. So remember, that's going to be, take the derivative, we get 1 over 1 plus this quantity squared. But remember, we also have to multiply by the derivative of the inside. Plus 1 over the square root of 1 minus y squared dy over dx equals 0, right? Because the derivative of any constant is 0. So we wind up getting that dy over dx, I'm just skipping steps left and right here, is going to be negative 2x over 1 plus this quantity squared divided by 1 over the square root of 1 minus y squared. Now this is kind of gross to look at, but also reasonable to simplify. This is going to be negative root 1 minus y squared. Right, and then it's going to be 1 plus x squared minus 1 quantity squared. Right, so we get that. So that's our answer.